Okay class, today we will discuss lateral magnification of the image formed by a refracting surface. So here we have only one refracting surface. We have only one refracting surface. Why I am writing this? Because if we have more than one refracting surface, then it will create an optical system. Okay, so here refraction will occur at the interface. Suppose this is the line which is dividing two media. Here we have another medium whose refractive index is mu2, and here the refractive index is mu1. Suppose this is the axis of the optical system here, okay, and we have here a point O dash whose direction cosines optical coordinates are defined by lambda1 and y1, and the ray propagates from this point to here. Here it moves up to P point within the same medium whose refractive index is mu1. So here this height, this is y1, and this point on the optic axis, that is O, and this distance is d1, object distance, okay, and here at this point on the interface refraction occurs, okay, refraction occurs. In the second medium I take this point to be Q, and from Q to, suppose here image is formed, refractive index of the second medium is mu2. Suppose image is formed here at I dash, and here the directions are optical coordinates are that of image, it is lambda2 and y2, okay. So here the height is y2, and at this point we get the image, and this distance in second medium, that is d2. So again from Q to I dash there is translation. So three phenomena are occurring here. From O dash to P there is translation. Let the coordinate of P are given by lambda dash and y dash, and coordinate of Q, those are given by lambda double dash and y double dash. Now we are to form a matrix which connect the coordinates of image with the coordinate of object, okay. So for that we will use the translation matrix and refraction matrix. So let us have idea of translation matrix. You see here translation. So translation occurs in between 2 points and in the same medium. For example, here O dash and P. So here class, translation occurs between 2 points O dash and P. Okay, and it is in the same medium. So there will be no any change in direction of the path. So the ray moves from O dash to P along a straight line, and at point Q.
Yeah.
So class, translation occurs in between these 2 points, and the matrix connecting the coordinate of P and O dash, that is given by this matrix. Okay, so this is 2 cross 2 matrix, and here D is the distance along optic axis in between these 2 points. जैसे O dash and P, these are 2 points, and the distance of the propagation along the optic axis, that is this distance D. It is D1 here, and at point P and Q there is a reflection. It occurs in between 2 mediums. So here refractive index changes. So there will be change in the path of light. Okay, there will be deviation. Okay, so the coordinates of these 2 points P and Q, those are connected using refraction matrix. Refraction occurs at the same point on the interface, and here refractive index changes and the coordinates of Q and P are connected using this matrix. It is a 2 cross 2 matrix. Here P is the power of the reflecting surface. So if for this surface you find the power, then it will be power P. This is refractive index of second medium minus refractive index of first medium divided by the radius. And what is this R? This R is the radius of curvature. You see, this is a spherical refracting surface. So if you complete this, then you will get a circle, and the radius of that circle, that sphere, is the radius of curvature. Okay, so without wasting time, let us complete the topic. So here I am writing whatever I have explained. I am writing that in words here. So you see, from O dash to P, there is translation. So here we will make use of translation matrix. You see here, translation is occurring, and for that, to connect the coordinates of P point, which are lambda dash and y dash, this will be, you will write here translation matrix, and that is 1 0, and d here we will take negative, because the distance is measured from this point, which is called pole of the spherical surface, and from here to here, this is d1, and the propagation of the ray is along this direction. This is left to right, and the measurement of distance d1 is from right to left, opposite direction you have. So you will take it negative. That's why I have put here a negative sign, and refractive index of this medium, and then I will write here 1, and then the coordinate of the object point, that is lambda 1 and y1. So this is lambda 1 and y1. In the same way, if we move from P to Q, these are in different media. So P to Q, to connect these coordinates, we will make use of refraction matrix, and a refraction matrix is, you see here, the coordinates of point Q, that is lambda double dash and y double dash, and here you will write refraction matrix, that is 1 minus P, and then 0, and here 1, and then coordinate of P, यानी कि first point on the interface, and that is lambda dash and y dash. Okay, now in between Q and I dash there is translation. So to connect the points of Q and I dash, I write here between Q to I dash there is translation. तो यहाँ पे क्या हो रहा है, ट्रांसलेशन हो रहा है, ठीक है। तो ट्रांसलेशन के लिए अर्थिंग के जो भी कोऑर्डिनेट्स उनको कैसे कनेक्ट करेंगे, lambda 2 and y2, this will be, here I will make use of translation matrix, that is 1 0 and d2 divided by mu 2, refractive index of second medium, and here we have 1. Okay, and then coordinate of the first point here is Q. So I will write here lambda double dash and y double dash. So this is how you can connect different coordinates. So now what we are to do? We are to establish a connection between the optical coordinates of image and the optical coordinates of object. So what you will do? We will start from this matrix, and in here we will put the value of lambda double dash and y double dash. This is the value of lambda double dash, y double dash, and after putting that we will put the value of lambda dash and y dash from this relation, and in this way you can connect the coordinates. Okay, now let me clear the board and start from here. So from here you have lambda 2 and y2, these are coordinates of the image, and this is equal to refraction matrix, translation matrix, that is d2, by mu 2, and here you have 1, and then you have lambda double dash and y double dash. Okay, so lambda double dash y double dash, from here you can put this relation. So here you will write 1 minus p, and here 0, and here you have 1, and then lambda dash and y dash. For lambda dash y dash you can put this relation. So here you will write 1 0 minus d1, and then mu 1, then 1, and then you have lambda 1 and y 1. So here lambda 1 and y 1. So in this way you can connect the coordinates of object point and image point. If you solve this, then you will get a matrix. Let me write it directly. Okay, so students, we have multiplied these three matrices, and this is the resultant matrix. Okay, now we will make this matrix a general matrix. Okay, now what is our task? Our task is we are to find magnification, we are to find lateral magnification given by the ratio of y2 and y1. So using these equations we will find the equation which connect y2 and y1, and for that y2 will be equal to, if you multiply these two matrices then and find the corresponding components and compare, then you will get this factor will get multiplied by this and this factor by this, and you will get the relation between y2 and y1. So from here you have d2 by mu 2 plus p d1 and d2 divided by refractive index of first medium, second medium, minus d1 object distance and refractive index of first medium, and then into lambda 1, and then this factor into this element into this, and you will get plus here minus image distance p power of the refracting surface, and then mu2 refractive index of second medium plus 1, and then y1 height of object. Okay, so from this equation, if we take now, if you remember the figure, then this was the figure, and here was the point O dash at a height of y1. If this object is at the axis, okay, then mean to say if we solve this for axial object, so for axial object, mean to say when the object is present at the axis, then y1 will be equal to 0. Okay, and the image will also be on the optic axis, mean to say y2, this will also be equal to 0. So for the axial object, okay, y1 and y2 both are 0. Okay, so if you put here 0 and 0, this factor will be equal to 0. So from here you can conclude that d2 by mu 2 and plus p d1 d2 divided by mu 1 and mu 2 minus d1 by mu 1, this will be equal to 0. Okay, so to make this matrix a general matrix, we have to put this factor equal to 0. So from here you see the matrix, final matrix reduces to, from here you have lambda 2 y2 coordinates of image, this will be equal to 1 plus p d1 object distance by refractive index of first medium, and then minus p, and here you have 0, this is 0, and minus d2p divided by refractive index of second medium, and then plus 1, and here you have the coordinates of object lambda 1 and y1. Okay. So class, we have to find magnification which is ratio of y2 and y1. From this equation again we will solve. We will get y2, this is equal to this into lambda 1, 0 into lambda 1 plus this factor into y1, that is minus d2 into p divided by mu2 plus 1 into y1. So from here you can find magnification. So this factor will be 0. तो इसको erase कर देते हैं. And if you take ratio of y2 and y1, you will get m. So the lateral magnification will be equal to m. This is equal to y2 by y1, y2 by y1, and this is 1 minus d2 p divided by mu2. Okay. So class, we have solved this equation. This is the relation between d1 and d2. d1 is the object distance and d2 is the image distance. So if you rearrange this equation and solve it for power, then take power on one side. Here from this equation we have power p d1 d2 divided by mu1 mu2. This is equal to, take this factor on right hand side, you will get d1 by mu1 minus d2 by mu2. Okay, now we are to get rid of this factor from left hand side. So you will multiply this whole equation by mu1 mu2 divided by d1 and d2. So from here you will get the power will be equal to, so here you see d1 and mu1, this factor will cancel, okay, and d1 by mu1, this factor will cancel, and here you get mu2 by d2, okay, minus here you will get mu1 and d2 mu2, this will cancel, and you will get mu1 by d1. Okay, and what is power? We have discussed, this is mu2 minus mu1 divided by r. Okay, so now what you will do, you will find the value of this factor. Now we are to substitute the value of this factor and we will find this value from here, from power relation. You see here, you have d2p divided by mu2, 1 minus this factor. So how you can obtain this relation from here? So from here, if we rearrange this equation, let me write this relation. This is p is mu2 by d2 minus mu1 by d1. Okay, so let me rearrange it. If we solve it, mu1 d1, take this factor on left hand side, and you have mu2 d2 minus power. Now what you need here, we want 1 here, 1 minus p d2 by mu2, then you will get this relation. So we have to multiply this equation by d2 by mu2. Okay, then what you will get on the left hand side, you will get mu1 by d1 into this factor d2 by mu2. Okay, and this will be equal to, here this factor will become 1 and minus power into d2 divided by mu2. So you see here, this factor is same, these two factors are same, so this is magnification. So mean to say, we can write this factor gives you magnification. So the magnification m, which is the ratio of y2 and y1, this will be equal to this factor. Or you can write 1 minus p d2 by mu2, and this is this factor, that is d2 by d1, and you can write here 1 by refractive index of second with respect to first medium. Okay, and what is this? This is refractive index of second with respect to first, that is mu2 by mu1. So this is how you can find the magnification.